Welcome to this e-lecture, which will be about hypothesis testing and the comparisons of means. So, what is the principle behind hypothesis testing and when we are going to test the differences between means? Well, we have a depend variable which we use to calculate the means that we are going to test the differences between, and the independent variable is used to construct the groups that we are going to compare the differences in means between. So we want to test whether there are differences on the dependent variable between these groups defined by the independent variable. And as for inferential statistics, if we compare two means, we use a set test or a t-test, and if we compare more than two means, we use the so-called f-test. And we are going to use an example from SPSS. We're going to look at attitudes towards parents beating children, and that's our depend variable. And in the first analysis, we're going to compare two means, and we're going to compare the difference by gender. So if we look at this table, we see that males are find it a bit more justifiable for parents to beat their children than women, because the mean is a bit higher. The scale is going from 1 never justifiable to 10 always justifiable. So both male and female are close to never justifiable, but males find it a bit more justifiable than female. And we're going to test whether this difference between males and females is significant, and whether we can generalize that to the population in the US, which is US people in the US in this example. And in the next example, we are also going to use attitudes towards parents beating children as the depend variable, but we're going to do a comparison between several means, and those are defined by age groups. So we're going to see whether there is a significant difference between different age groups. And as you can see, the younger ones tends to be a bit more inclined to say that it's more justifiable for parents to beat their children than the older ones. And again, the scale is from 1 never justifiable to 10 always justifiable. And it's a question about measurement. Well, this variable is strictly speaking on the ordinal level, because it's there's a range. You can say that, okay, 2 is more than 1 is more than, or 3 is more than 2, and so on. So there's a range, but you cannot really say that 2 is twice as much as 1 and 4 is twice as much as 2. So you're not actually at the interval level, but we use this, given that the scale is quite. There's quite a large scale, and it's a quite fine scaled variable. We use it as it's almost at the interval level, and thus we can make means based on this for different group based on this depend variable. So inferential statistics 2 means, we start out by defining a null hypothesis or no difference. There's no difference in the means on the depend variable between the two groups in the population. The observed difference is due to sampling error and does not reflect the difference in the population. So if the null hypothesis is true, we think that the difference we have found between males and females are due to sampling error and is not reflecting a true or a real difference in the population. And if the risk of getting this the sample difference, given that H0 is correct, is lower than the chosen level of significance, usually 5%, we reject H0. So if this difference we find is the chance of getting that is very, very low, given that H0 is very, very low, and it's less than 5%, well, then we are more than 95% sure, or more than 95% sure, that H0 is not correct. So there is actually a difference. So if the chance of there not being a difference is 5% or less than 5%, then we reject H0, saying that there is no difference. The likelihood distribution is the normal distribution in this instance. So we say that we have H0 here in the middle, and if we get a sampling results that is very far from H0, either in this area or in this area, we reject H0, saying there is no difference between, in our example, men and women. So the more standard errors the sample result deviates from the null hypothesis, the less likely that this result is due to sampling error from the population with no difference in the means between the groups. So we say that, okay, if we end up in this area or this area, we find it very unlikely that H0 is true, that there is no difference between the groups. We think that, well, probably it's very likely, 95% or more likely, that there is actually a difference between the groups. So the z-test, the t-test, and the p-value, we measure how far the observed sample difference is from the null hypothesis, no association. This distance is measured in terms of standard errors. And from this distance, one can calculate the probability that one would observe this the sample difference, given that H0 is correct, and that's the p-value. And statistical software always report the p-value, and H0 is rejected when the p-value is lower than the significance level, usually 5%. So the procedure is, you state a null hypothesis and an alternative hypothesis, you choose the level of significance, usually 5%, you determine the appropriate statistical method. If it's a large sample, you use a z-test, if you have a small sample, you use a t-test, and you test whether, and when you're going to test the difference between two means, and using a z-test or a t-test, first you have to test whether the population variance are equal or not. That's the Levin's test. I'm going to show you how to use that afterwards. And you estimate the standard error of the difference, and then you can then calculate the p-value, and SPSS does this, and decide whether to reject H0 or not. And how we do this in SPSS? Well, we choose analyze, compare means, and independent sample t-test, and then over in the test variable we put the depend variable, which is in this case justifiable for parents to beat their children, and we define the groups, which is 1 is men and 2 are women. And then we test the hypothesis where H0 is, or the null hypothesis is that the average attitude is equal for men and women, and the alternative hypothesis is that the average attitude is not equal for men and women. And then we get this result. So the first thing we have to look at is whether this test is significant or not. Because the procedure for computing the standard errors depend on whether the variance in the two populations are equal or not, and the standard errors go into the calculation of the p-value. And so thus we first have to test the H0 of the variance, whether the variance is equal or not. And if this is significant, we read the... If this test is significant, we read the second line of the test. If it's not significant, we read the first line of the test. And please do note that these results are often the same, so it doesn't really make a huge difference whether you read this or not. But if it's significant, you should read the second line. If it's not significant, you should read the first line. And in this instance, in our example, it's significant, so we read the second line. And as you can see, the p-value is much lower than our chosen level of significance, so we reject H0, saying that there is no difference between men and women. And here you can see, so you really find out, you test this difference between men and women, and the fact that male tend to say that it's more justifiable for parents to beat their children, and we see that, okay, yeah, there is actually a difference, and this difference can be generalized to the population. And we have inferential statistics several means. We also start out by the null hypothesis of no difference. The null hypothesis, all of the groups have the same mean on the dependent variable in the population. The absurd difference is due to sampling error and does not reflect the real difference in the population. And if at least two of the groups have different means in the population, the null hypothesis is not correct. And the risk of getting the sample difference giving that H0, or the null hypothesis, is correct. If that's lower than the chosen significance level, and it's usually 5%, we reject H0. Because if we find out that the risk of getting this difference in our sample is lower, is 5% or lower, we can be 95% sure or more sure that H0 is not correct. So then we use the F-test. And for the F-test, we split the total variation in the dependent variable into variation that is due to differences in means between groups and variation around the mean within each group. And from this we estimate the mean squares, or the variance. And if the null hypothesis is true, the two sources of variance, the one between groups and the one within groups, should be approximately equal. But if the null hypothesis is not correct, the difference between groups should be somewhat larger. And one can calculate the probability of observing the sample difference in means, giving that the H0 is correct, and that's the p-value. And statistical software always report the p-value. And H0 is rejected when the p-value is lower than the level of significance level. So if the risk of getting this result, given that H0 is correct, is lower than our level of significance, we reject H0. And the F distribution looks like this. It's equal to the normality distribution, but it differs a bit. So the procedure is, we state the null and alternative hypothesis. We choose a level of significance, usually 5%. We determine the appropriate statistical method, which is the F-test. We calculate the p-value, and SPSS does this for us, and we decide whether H0 is to be rejected, or null hypothesis to be rejected or not, by comparing the p-value to our chosen level of significance. And in this example, or when we are testing the difference between several means, we also get the proportion of explained variance. And the total sum of squares can be split into two parts. That's the explained sum of squares and the unexplained sum of squares. And how much of the variance is so the explained sum of squares are ESS, and the unexplained sum of squares our variance is USS. And how much variance is explained by the model? Well, here we have the eta square, which equals R square, where you take the explained sum of squares and divide it by the total sum of squares, and then you get the total explained sum of squares. So then you know how much the dependent variable explains of the total variation in the dependent variable. Okay, so if you have SPSS and you want to test several means, you choose analyze, compare means, And then in the depend list, you put the depend variable, which is justifiable for parents to beat their children. And in the independent list, you put the age groups. And you also have to click on options, and then tick off for the ANOVA table and ETA to get the how much of the variation the model explains, how much the depend variable explains of the variation in the independent variable explains of the variation in the depend variable. So, and we test the hypothesis. The average attitude is equal for all age group. That's the null hypothesis. And the alternative hypothesis is the average attitude is not equal for at least 2 age groups in the population. And then we get this result. We see that there is a difference for the age groups, but is this significant? Yes, it is, because our p-value is much lower than our chosen level of significance, which is 5%. So we reject H0, given that this is much lower than the chosen level of significance. And we see that eta square, which is the same as r square, is just 0.019, which means that the model explains, or age explains, about 2% of the variation in attitudes towards parents beating their children. So that was the e-lecture about hypothesis testing and comparisons of means. Thank you so much.